So hello everyone, and welcome to today's special webinar organized by the MDPI in celebration of 2025 Nobel Prize in Physics. My name is Nemanja, and I'm delighted to be your host for this event today. Before we begin, I'd like to briefly introduce the MDPI for those of you joining us for the first time. So, founded in 1996, MDPI is the pioneer on scholarly open access publishing, headquartered in Basel, Switzerland. We are proud to support the global academic community through a portfolio of over 470 different and diverse and high-quality open access journals across all subjects and disciplines. Among them are the two journals, Condensed Matter and Universe, which are co-organizers of today's webinar. So I will just like to introduce them quickly as well. So Condensed Matter is an international peer-reviewed and open access journal that focuses on the physics of the condensed matter. And the Universe is the peer-reviewed open access journal focused on theoretical, experimental, and observational progress in fundamental and applied physics from circumterrestrial space to cosmological scenarios as well. Both of them are published by MDPI, and both of the journals are indexed in the leading scientific databases and supported by outstanding academic editorial boards. Also, here, moving forward, you can see the program for today. The webinar will be sectioned in several sections. We will have expert commentary, and then short break, after which we will announce the winners of the Nobel Prize. And after that, we will have another reflective discussion with our speakers for today. So today, we are honored to host this expert discussion featuring distinguished editors from our journals. Please let me to introduce them first. First speaker for today is Dr. Amir Abbas Haghighat from the Institute of Quantum Materials and Technologies in Karlsruhe Institute of Technology in Germany. And also beside that, he is the section editor-in-chief of the Condensed Matter Journal. Our second speaker for today is Professor Dr. Mate Shanad. He's from the Department of Atomic Physics, Faculty of Science of Eötvös Loránd University in Budapest, Hungary. And he is also section editor-in-chief of the Universe Journal. Our third speaker for today is Professor Dr. Mariusz Dąbrowski from Szczecin Cosmology Group, Institute of Physics in Poland, and he is one of the associate editors of the Universe. Thank you very much for joining us today, and we are looking forward to your thought-provoking discussion about the current and future impacts of the physics research, and also reflections on this year's Nobel laureates. So let's first begin with our first section, which is the expert commentary segment. So to start, could you please tell us about your area of expertise and how you have contributed to the physics research through your work so far? We can start, for example, with Professor Haghighat. So please.
Yeah, thank you very much for the nice introduction. My name is Amir Haghighat. I'm from Karlsruhe Institute of Technology in the Institute of Quantum Materials and Technologies. I'm a condensed matter physicist, specializing in discovery and investigation of novel quantum materials. And my work focuses on synthesis of high-quality single crystals that serve as a platform for exploring emergent electronic, magnetic phenomena arising from strong correlations like spin-orbit coupling and topological effects. And then I combine this precise materials growth with detailed measurements like transport, magnetization, thermodynamic properties to uncover a fundamental relationship between crystal structure and quantum behavior. And I'm glad to have that is announced today the Nobel Prize for Physics for a very fundamental aspect in the quantum mechanics. And by that, I give the word to the next participant.
Thank you very much, Professor. Professor Janat, can you let us know about your contributions to the research in physics?
Yes, hi. I also welcome everyone who is attending here. My name is Máté Csanád. I work at Eötvös University, but my field is related to particle accelerators, out of which there are just a couple in the world. These are large-scale experiments which aim to recreate the first microsecond after the Big Bang, the hot and dense matter that filled the universe in those first moments of its existence. And this matter can be recreated by ultra-relativistic collisions of particles or nuclei in accelerators such as the LHC in Switzerland or the relativistic heavy ion collider in Brookhaven in the US. And my field of study is to investigate the space-time evolution of this matter until it freezes out to conventional particles and then can be detected.
Thank you very much. Also, Professor Dombrovsky, I understood that you have some slides that you would like to share. I will stop
Okay,
sharing my
yes,
screen so
I
you
can do,
it.
yes. It will be quicker, I guess.
Yeah. So please proceed with sharing the screen.
Yes, okay. Just a few words about myself. Okay, I am, as I said, as it was said already, I'm the head of the Szczecin Cosmology Group, which I in fact created and now are leading. I am also affiliated to the National Center for Nuclear Research in Poland, near to Warsaw, and related to two foundations. One is the Research Foundation, it's Copernicus Center. It deals with philosophy of physics and things like that too. It's in Kraków, Poland, and I'm the president of the Eureka Foundation, which is popularizing science. Among others, we popularized Nobel Prize issues last year very strongly. My field of work is cosmology, and cosmology, but cosmology is a broad area. And this is in homogeneous cosmologies, pre-Big Bang, superstring brane cosmologies, which were actually, I dealt with that in the 90s of last century, early 2000s. Then cyclic cosmologies, multiverse, say multiverse issues, quantum entanglement of the multiverse within the multiverse. I issued an MDPI volume for the universe called The Multiverse. And as for my achievements, I highlighted some of them, but I could say that what maybe fits towards today's the Nobel Prize winners is that I proved with Arne Larsen in 1995 that there exists some macroscopic quantum tunneling effects at the maximum of expansion of the universe. I also explored some exotic, non-standard singularities in cosmology and discovered one of them called W singularity. With my colleague from the Szczecin Cosmology Group, I also, with Vincenzo Zalzano, we suggested the test a la Römer of variability of the speed of light due to the measurement of cosmological measurement due to maximum angular diameter distance test related to baryon acoustic oscillations. Thank you very much.
Thank you very much, Professor Dombrowski. I will share the screen once again. Thank you very much for letting us know about all the interesting things that you do. So I think we can go to the second question. And can you let us know, in your opinion, what have been some of the major breakthroughs in the physics research in the recent years? And also, what do you think, how has the Nobel Prize reflected these breakthroughs in the past? We can go in the same order that we did it before. Professor Hagigard, can you start?
Yes, I will maybe be a bit short on that so that I give the opportunity also to others to give some view of it. So I think there are several breakthroughs, but in different subsections of physics. Certainly the AI, artificial intelligence and data-driven physics, is quite important. So machine learning, data analysis, and so on. The second one that I think is the quantum technologies like quantum computing, quantum communications, new phases of matter and quantum materials. So discovery of topological materials, time crystals, and conventional superconductors, etc. Energy, climate, and sustainability physics, like climate modeling, development of high efficiency photovoltaics, interdisciplinary and complexity physics, so applied physical principles in biology and biological systems, instrumentation, computational advances, and maybe some big picture, let's say, in physics, explaining the universe to engineering it atom by atom, qubit by qubit, and dataset by dataset. And with this, I maybe give the word to the next person to complete that or give their views on it.
Thank you very much. Professor Tranat, can you also give us your thoughts about this?
Yeah, so breakthrough is an interesting word, and it can mean many things. And of course, I guess each of us experience breakthroughs every day or every week when one does some research and faces some obstacle. But if you mean major breakthroughs, then it's also hard to assess what constitutes a breakthrough. For example, quantum physics is 100 years old today, and that was a major breakthrough. And I think we, since then, or at least since the 20th century, maybe don't see this big of changes in physics, but some examples are detection of gravitational waves by LIGO and later on Virgo as well, and or advances in quantum computing, for example, or this year the Breakthrough Prize was given to the LHC experiments for their including the discovery of the Higgs and some other results from their long run, which our group also shared. And but these go to thousands of people these days, so these are very different from those breakthroughs of the 20th century, which were achieved by single people.
Yeah, thank you very much for your thoughts. Professor Dombrowski, can you also?
Yes, okay, maybe I will not use the slides, just comment. I think that generally the Nobels in recent years have reflected the progress and main breakthroughs in the field of physics, but I can say personally that there were some inaccuracies, according to my view, on which I will conclude in a moment. Saying examples, it was already mentioned that the discovery of gravitational waves surely deserved Nobel. And it happened immediately in 2017 to Rainer Weiss, Kip Thorne, and Barry Barish. But the problem was, as my colleague already mentioned, that hundreds of people in different groups were working on that. And Nobel said not more than 3 awardees. And this makes a barrier which requires the selection. And the selection in this case, okay, is hard. As for the 2011 Nobel Prize awarded to Saul Perlmutter and Brian Schmidt and Adam Rees for the discovery of the accelerated expansion of the universe, it seemed that it was easier with the selection since they were really team leaders and also the main contributors who suggested the methods to observe supernovae. Similarly, so I think reflecting the trend and the breakthroughs was the Peter Higgs Award with François Englert in 2013 for obviously for the Higgs mechanism, as we all know. But as I already has mentioned, there have also been some inconsistencies according to my personal view, not awarding, for example, Nobel to Alex Wolszczan, discoverer of the first extrasolar planets around the pulsar PSA B1257+12 in 1990. Maybe I'm biased because Wolszczan, before emigrated to the US, was living in my city, Szczecin, and later kept in touch with our group and university. But the fact was that he first pointed out really existing planets and not just made speculations. The prize, in fact, went in 2019 to Michel Mayor and Didier Queloz for the discovery of an exoplanet orbiting a solar-type star, which means that not a pulsar, but a solar type. But it was, in fact, Alex Wolszczan who first made kind of a Copernicus-like breakthrough showing that the planets exist. I consider it kind of analogy to what happened in 1967 to Jocelyn Bell Burnell. Today there were also speculations about whether the woman can get the Nobel Prize. Today it emerged that it was not the case. But Jocelyn Bell Burnell in fact discovered pulsars, but the prize was awarded to her supervisor. And of course everybody now knows that she was the discoverer, while with Alex Wolszczan it's a bit different because he is somewhat forgotten nowadays and not very often mentioned as first planet discoverer. So as you see, there are some ups and downs which are related, but in general I think Nobels somehow reflect the state of the science in our planet. Thank you.
Thank you very much for this response. It was very interesting. Also, could you let us know about what are some of the key trends that are driving the innovation in physics today? Some of you already mentioned AI and their impact on the physics research. So can you let us a little about this, and also what will be the future impact of these innovations that we can have now?
Yes, I think this is a very interesting question. So I think we have today seen that the Nobel Prize was given for a very fundamental aspect. So and with that, not only, let's say, impacting physics, but also other disciplines. So I mean, there is actually some boundaries between disciplines that are dissolving, I think. This is good because we get, let's say, from different disciplines, discoveries and impacts, certainly also on the society. One very important aspect of the Nobel Prize is what is the impact on the society. So I think data, quantum control, sustainability, this is, let's say, our century physics. And I think the future Nobel Prize also will come from a lot from quantum information, fusion breakthroughs, and multi-messenger discoveries. So I think this part of the fundamental physics of quantum mechanics that relates to quantum information and makes it possible. I mean, we have today seen the real quantum effect of the of today's Nobel Prize was discovered by Joseph Brian Josephson. Okay, but it got the touch into this macroscopic feature, which makes it very feasible and closer to reality, because that is what we would like to have in on our planet, living from materialism, from materials, and what happens in deep in the physics of those materials. So I think, to be short, quantum technologies is going to be the future, at least the development of the research in physics in different areas. So I'm not saying specifically in one subtopic, but it's going to be in many disciplines, and they're going to use that in different area, but all with the same principle. So that's my view of it.
Thank you very much. Dr. Janat, can you also give us your thoughts about this?
Yes, I certainly agree that that quantum physics, quantum technologies, and many of those aspects will be or are key trends driving innovation and physics research. But maybe I can touch back on what I mentioned already in the previous block, that a trend that cannot be evaded basically is the research groups growing and growing. And these days, innovation and research is done in sometimes many thousands of people, large groups, such as at CERN, and these groups are sometimes lacking one figure that they promote as the face of the or the main innovator behind the research. And CERN is, for example, very strict on not singling out everyone, but listing people alphabetically. And one of the impacts of these trends will be that the Nobel Committee will have a harder and harder job in the future, where groups will definitely grow. And the Nobel Committee already faced serious criticism of not involving people in the past, and this will just be stronger in the future. But this is more a sociological type of impact. Of course, we expect that all physics research has a direct impact of what of our lives here. And while the impact of discovery of electromagnetism took a couple hundred years, the discovery of the strong interaction took a little bit less. It's still being researched today, but it already has applications in the medical field. And maybe if we discover a fifth force, then that will have an even faster impact, but would certainly lead to a Nobel Prize.
Yeah, thank you very much. Professor Dombrowski, can you also let us know?
Yes, I think I'm in tune with the colleagues. Okay, I agree that nowadays the progress in the world is dominated definitely by information technology. It influences all the fields of, I say, inverted commas, classical sciences, as presented by the Swedish academic classes. Computational market has made much bigger progress than any other branch of technology, and it even dominated the energy market recently. So we are now totally digitalized every day, beginning with smartphones, computers, but also with our cars, bikes, houses, etc. So in fact, computational methods entered as tools every classical science, physics, chemistry, biology, by the application of the neural networks, machine learning, and then AI, helping to collect and verify the data, to perform some visualizations, simulations, advanced calculations, which help progressing these fields. The problem is that the boundary between the merit of a discipline like physics, chemistry, and the tool, which are computational methods, have become a bit fuzzy, and we do not know exactly for what the award, the Nobel Prize, should be given. According to Alfred Nobel, it is a citing, yes, for the most important discovery or invention in physics. Last year's Nobel awarded to John Hopfield and Geoffrey Hinton for foundational discoveries and inventions that enable machine learning with artificial neural network was considered by many as the physics Nobel stolen by a different discipline. And then perhaps Nobel Committee should consider a new category exactly in the field of computing science, despite the original Nobel will. It happened with the Nobel Prize in Economy, as far as I know. To conclude and actually to support the proper award, not just award which is slightly outside of the range of the pure physics, Nobel 2022 for Alan Aspect et al. And John Clauser and Anton Zeilinger for experiments with entangled photons, establishing the violation of Bell inequalities and pioneering quantum information science, was surely appropriate for the physics, since it related to the merit of physics and not to the tool, which, as I said, is more like a method of computing than pure discovery in physics. Thank you.
Thank you very much. Could you let us know about your predictions for this year's Nobel Prize? What sort of the scholars, and regarding which topics do you think it will be awarded to? I know that some of you may already seen the winners of the Nobel Prize for this year, but could you just give us a quick thoughts?
To be honest, I didn't have the prediction for this year's Nobel Prize with the topic of Josephson tunneling, but what I was thinking that maybe it deserves a Nobel Prize was about this quantum information metamaterials. And was thinking, of course, the Nobel Prize is given either to one or to 1 to 3 people, and but maybe Peter Shor, Gilles Brassard, Charles Bennett, and David Deutsch. I think they deserve also, in my view, the Nobel Prize. But I didn't think really about let's say John Clark and the possibility to get the Nobel Prize this year. But there are, of course, the world of physics is quite large. One cannot grasp. I'm myself from the condensed matter physics, so I'm not grasping all the aspects of physics and highlights. Well, occasionally when we read in prominent journals, but my if I'm really honest, in articles like Nature, who, let's say, publish prominent works, it's full of right at the moment is full of this quantum information and medical physics, etc. So it was hard to predict. But my guess went to quantum information metamaterials.
Thank you. What about our other speakers, Professor Chanad and Professor Dombrowski?
Yes, so actually, I also don't usually predict these things. You know that Niels Bohr said it's very hard to make predictions, especially about the future. But now we are in a good phase that we have to be. You are asked about the predictions about the past, so this is much easier. But looking at some predictions made by several journals and portals. What caught my eye is the chances for Aharonov and Berry and topological physics, which would have been extremely nice, but certainly something aligned with all the quantum research going on is would have certainly deserved the prize this year as well.
Professor Dombrowski?
Okay, I can say what was my expectation and what was my wish. First, I start with my wish. My wish was to have the Nobel this year awarded in astroparticle physics and cosmology, which is for the theory of cosmological inflation, which predicts the tiny primordial fluctuations of density that brought our galaxies around us a reality. That's the main achievement of inflation. Surely 3 people deserve an award, Alan Good, Andrei Linde, and Alexei Starobinsky. The last of them sadly died already in 2022, so he couldn't have it. But I knew Alexei very well, and he visited our group for conferences a number of times, and recently online 2021. And I can say that he was really an extraordinary scientist and a smart man. That was my wish. As for the expectation, I could agree with my colleagues that quantum computing field last year it went to AI people, I would say, or more practical tools rather than merit. And this year I was expecting that the prize would be awarded to Peter Shor for quantum algorithms being the base of Google's Sycamore supremacy claim to IBM's 1000 qubit computer. Which in fact, according to calculations, would be more than entropy than the universe has, because the universe has only 400 qubits entropy. And a feat to my interest about the multiverse would also make an award to David Deutsch, who suggested a universality of quantum computer. And spin qubits, maybe Daniel Loss, David DiVincenzo. Okay, these are the people. And I agree with I think, Professor Chanat, that another option which was, say, on the market was the Yakir Aharonov and Sir Michael Berry for all these geometric topological wave functions, twists, and the discovery where they actually create their theories already in 1959 and then 1984. So as we know, today's Nobel is for the discovery 40 years old. So they still these two guys, Aharonov and Berry, deserved. Among less known types, I would say there is a nice physicist, Constantino Tsalis, who proposed some non-extensive entropies, better describing long-range correlated systems in thermodynamics, which have also proven useful, not only in physics. And maybe he is already more than 80, but maybe one day he could also deserve. But it's more like my wish and not the type which was actually announced too much on the press. Although the first one, I think people are still thinking about inflationary scenario, inflationary theory to be awarded by the guys who invented it. Thank you.
Thank you very much. I think with this we can end this segment of the webinar. We will go to a short 5-minute break, after which we will read the winners of this year's Nobel Prize in Physics, and also we will have more discussion about the current winners. So I think we can make a short break here. Okay, welcome back everyone. I think we can continue with our today's webinar. So first, we would like to announce the winners of the 2025 Nobel Prize in Physics. This year, the prize was awarded to John Clark, Michael Devoret, and also John Martins for demonstrating quantum mechanical tunneling and energy quantization in macroscopic electrical circuits. Their groundbreaking experiments with superconducting Josephson junctions showed that the quantum phenomena can occur in systems large enough to see and handle, paving the way for advancements in quantum technologies like quantum computing and sensing. Now we can discuss this further. I would like to ask our speakers today, what are your thoughts on the winners of the Nobel Prize this year? Do you think they were chosen, why they were chosen, and why is their research so significant to the field? We can start with any of our guests here. So you can start if you wish.
Shall I start again?
Yeah, that's okay.
Yeah, I mean, it's quite nice to that it was let's say given to John Clark and Michel Devoret and John Martinez. So I think let's put it very short. It is quite significant because this let's say Nobel Prize, because it bridges the gap, in fact, between the quantum, where we say, okay, very small world, and the classical world, and that it shows that the quantum effects can manifest in devices you can hold or engineer. I think this is the most important one important part. It's not only, let's say, a discovery of quantum mechanics, as we already said before, my colleagues, that over 100 years ago was set up by many big names in the physics that we know, but it is it has to have some achievability. So even Einstein was thinking about, he was a deterministic, so about his way of thinking in of quantum mechanics. But today it has changed a lot. So this Nobel Prize is essential for quantum technologies, quantum computers, even if I'm of opinion that the quantum computers are still quite far away from what is in the reality. Quantum sensors or quantum communications like cryptography and so on. I think this discovery actually deepens the understanding of quantum mechanics itself. That means it's thought limited to isolated microscopic systems that can extend to macroscopic systems, and like at low temperatures we have in superconductivity, etc. So I think it's quite significant, and as I said before, it will also avail the possibility between different disciplines. Yeah, no matter whether it is in cosmology or it is in biophysics, or the fundamentals of this quantum mechanics is, I think, essential for many disciplines. And that is, I think, the most important part of to my point of view, of this Nobel Prize today.
Thank you very much, Professor. Professor Janat, can you also give us some thoughts about this?
Yeah, I completely agree on that, first of all, this research will be important just within the field of quantum computing and quantum algorithms and so on, but also, and in my view, it's more important on a fundamental level to understand what quantum mechanics is, and I think it's today one of the most important questions of physics in general, how we can understand quantum physics, and if quantum physics describes reality, or if there is a reality at all. These are fundamental questions that are unknown since 100 years, or different physicists have different takes on them, and proving that core ideas of quantum mechanics work in macroscopic systems, or mesoscopic maybe, so somewhat larger than just particles, is really, really important. Some of the previous Nobel Prizes were also partly, at least, awarded because people could see quantum phenomena with larger and larger objects, such as moving from electrons to atoms, and from atoms to molecules, and single molecular interference, and so on. Many phenomena were presenting breakthroughs in physics, and I think showing that close to macroscopic objects can also experience these phenomena is fundamentally extremely important towards quantum physics, which forms the foundations of indeed many fields. For also, I add to the list previously given the particle and nuclear physics, which are entirely based on quantum physics and quantum field theory. So having the foundations right is extremely important.
Yeah, thank you very much. Professor Dombrowski, could you also?
Yes, I think that we have again the same issue related to the somehow computing science dominating the world, I would say. In principle, the committee selects out of, say, many kind of breakthroughs in various fields of physics, okay? Because physics is not just one field, but there are some fields like particle physics, condensed matter, etc. And it seems that there have not been any award in atomic, molecular, and optical physics since 2018. And in condensed matter also, it was not any Nobel since 2016, which was awarded by Thales, Haldane, and Kosterlitz. And there was kind of a surplus of awards in quantum computing and quantum information, and also say cosmology or astrophysics. So the committee probably decided to balance this gap, but still keeping this computing or quantum computing in mind. Yes, this there was an issue of, say, condensed matter, which could be already mentioned by one of my colleagues for the metamaterials with theorist John Pendry and experimentalist David Smith eventually, but the committee actually awarded the other people, Clark, Devoré, and Martinis, as we know. It's interesting that it actually, the prize was awarded after 4 years after the actual discovery of what they have done. Actually, it's interesting that the oldest awardee, John B. Goodenough, was 97 when getting the Nobel in chemistry in 2019. So, okay, sometimes you have to really wait a long time for the award. Surely, I could say that, I mean, my colleagues mentioned that, but I am more radical. I think that quantum physics rules our world, and the classical behavior of the systems seems to be just property of the macroscopic objects. We call it decoherence in terms of the quantum theory. Like macroscopic objects like football or a glass or I don't know, a spoon or something. So this year's actually awardees discovery having the system of particles moving through the superconductor which behave like a single particle, trapping the system in a state of 0 voltage, okay, and then say, so being kind of behind the potential barrier, and then showed that the system can escape via quantum tunneling, and the voltage shows up, is really kind of an interesting, I mean, very important discovery. It's purely the underlying effect in quantum theory, which is the macroscopic, the quantum tunneling effect. And in particular, it is considered as the symptom of macroscopic quantum tunneling effect. So I'm also very, very glad of having this, say, small system, but with macroscopic, or at least considered macroscopic quantum effect in the context of my pieces of research, inspired by early ideas of my colleague Klaus Kiefer from Cologne and his supervisor Dieter Zey, which were devoted to the effects of quantum tunneling of macroscopic universes, because in cosmology we have the quantum cosmology, not only classical Einstein cosmology, but quantum cosmology. And what we found that with my colleague Arne Larsen from Odense, Denmark, that it happened that the universe can quantum mechanically tunnel into the regime of oscillations at the maximum expansion. And the universe is huge in this case. So there is some interesting story about this. So I'm happy that the Nobel 2025 also shows the validity of these quantum tunneling effects in condensed matter, more close to the Earth, as my colleagues sometimes complain that I'm dealing with the universe and they deal with laboratories. So we in the laboratory effect, macroscopic effect for the quantum theory. Thank you very much.
Thank you very much to you as well for your answer. Also, I would like to just ask you here, what broader significance does the Nobel Prize holds up for society, and how it might shape our collective future beyond the scientific community? So we can also start with Professor Hagrihar.
Um, can you make it a bit more specific? I just didn't grab really what.
Yeah, in your words, can you let us know what broader significance does the Nobel Prize holds for the society and how it may shape our collective future beyond just the scientific community, like how it can this be beneficial for the general public?
Okay. I think we have in our uh, whole discussion also made some link to it. I mean, I just want to give an example of, let's say, the mobile phone that everybody has in his hands, and out of that it consists out of many um, uh, parts that really the working principle relies uh, on physics. So I think this way of really making it possible to see a quantum effect on macroscopic level makes it possible to really um, go beyond what technologies that we have today. So I think things become fast. It's not that I say that it is better. That for certainly is we human beings are limited, but I think it makes our life different. It has already, it has already uh, made it different. So we see it already in the artificial technology, yeah, ChatGPT. It's used in many different branches in the of physics, material science, chemistry, everywhere it's used. And I don't know if it is right at the moment. Maybe there are many people who are against it, but it has some aspects that you can't get, uh, let's say, look over it. So I think this possibility that linking the quantum physics, maybe the bottom line is like that I'm saying, the linking the quantum physics to our daily life, that is, I think, the message uh, of this Nobel Prize. And the second thing is what I found from this. You asked about the effect on the social, on the society, but also political. I think the three Nobel Prizes were given to three scientists from the US, and I think this shows that science is quite important in regard to what maybe the politics right at the moment think. And that is, I think, also a very important message. It's not only that within our field it reflects that maybe quantum mechanics is very important, but also I think on the political and societal aspect, it's quite important. Did I answer your question well?
Yeah, pretty much. Professor Chanat, can you also give us some thoughts about this?
Yeah, I completely agree with these thoughts, and would just like to reiterate them that on one hand, this year's Nobel Prize is, or the research behind this year's Nobel Prize is quite important for conventional computing in form of semiconductors that are the basis of everything, including this Zoom session that we are having right now, but also for the next generation of computing, if quantum computing ever becomes a large-scale reality. But quantum cryptography can also be named. But looking at the bigger picture, the Nobel Prize itself is important because it puts a couple of scientists onto some kind of a pedestal, selects some of the most important discoveries, and indeed has a way of shaping society. And for example, looking at the composition of Nobel Prize winners, of selecting, for example, female Nobel Prize winners in the future. These all hold keys to shaping our society.
Thank you very much, Professor Dombrowski. Do you also have any comments on this?
Yes, I do. I think that Nobel Prize in Science is like a golden Olympic medal in sport. I know what I'm talking about because last week I interviewed a golden medal winner in sport about the physics of sports, in fact. And I know that this makes the Nobel and the golden medal they make a unique influence into a person who awarded it, okay? And the person feels this, and also the society feels this. It also influences the society in a way that the society, they receive a clear message. There was some extraordinary achievement, like in sport. Please be aware of that. And public, in fact, pays for the science. It's not old times where the noblemen pay. And it returns something. So the scientists returns something which sooner or later will improve the quality of the human life. Sooner, like with some practical discoveries I already mentioned, giant magnetoresistance Nobel 2007 or light emitting diodes in 2014, or later the discoveries which we do not know yet for what they are, like neutrino discovery Nobel by Frederick Reines 95, or already mentioned gravitational waves. We don't know yet for what they would be needed for the humanity. The whole machinery, inverted commas, of Nobel nominations, which is very, very complicated, in fact, involving a couple of thousands invitations from the Nobel Committee, the engagement of vast part of the scientific community, and then the public, makes the whole story of the Nobel Prize kind of a legend, in inverted commas, influencing the society. Okay, it's announced everywhere. People are talking about it. Although this is not the highest financial value prize, it's just €1 million, and some other prizes like Templeton Prize for establishing the links between the science and the religion, which, by the way, was awarded by many physicists, the Nobel still has gained the highest reputation among all these prizes now. Being a young scientist, starting the career and not dreaming on awarding the Nobel Prize is something which I think deprives him or her a drive to discover things and be first, who does this in analogy to the Olympic record. So it deprives a young man, and I experience already that some young people do not know why they are working in science. I will finish with my favorite motto in the context of the Nobel by Galileo Galilei, since I was born on the same day of the year as him, who said, "It is easy to understand the things which are discovered, but the point is to discover them." Thank you very much.
Thank you very much as well for the interesting analogy. So I think we have also some questions from our viewers in the chat. Jorge would like to know what do you think about the present crisis of the cosmological models created by Hubble tension and possible large-scale anisotropies? Professor Dombrowski, you said that
Okay,
you would
yes,
like
I can
to.
say I'm an older man since I was dealing already with dark energy, now it's called, in 80s, the previous century, since I finished my studies. I was dealing with the cosmological constant models, negative pressure, cosmic strings, domain walls models, asking people like Alexei Starobinsky, later earlier Zeldovich, about all these. And this is the second crisis or related to H0 in cosmology, because in crisis, inverted commas, because it always refers to the precision of the measurement, okay? So we had, or not necessarily the precision, but the tools and the methods we are using. In the 80s and 90s, there was a crisis between the two groups, the group of Sandage and the group of De Vaucouleurs. One group was measuring the Hubble parameter 50, and another was measuring 100. Okay, and it emerged that having the Nobel Prize, actually people who invented the method of catching supernova and observing them properly reduced the crisis definitely, and we now are between 67 and 72. So it reduced, say, of the order of magnitude. Okay, I can say generally that first thing is that there must be some problem either with the method of measuring, because the first measurement is from the early universe, cosmic microwave background, and another with the late universe. So there is some discrepancy between these two patches of the universe. And I think that this must be settled somehow on the level of the measurement of the tools or methodology, or there is some fundamental around this, and it relates to the anisotropies or cosmic dipoles, which may suggest that the universe, the assumption of the so-called, it's often at the conferences on cosmology that they are making precision cosmology, and precision cosmology, and that there is a model independent cosmology. It's not model independent because the model is homogeneous and isotropic universe, which already assumes that there are no anisotropies, which in fact from time to time there is a collection of data about it. I think my colleague Leandros Perivolaropoulos from Greece has written some review paper recently about it, that there might be that the universe is not so homogeneous and isotropic. In fact, I asked a couple, 3 years ago, Adam Rees about it on one of the conferences, and he didn't exclude the possibility that there can be some anisotropies and inhomogeneities in the universe. I think that that could be the answer.
Thank you very much for a detailed response. Do any of other two speakers also would like to comment on this question?
No, great summary.
Dr. Professor Hagrihar, do you maybe have any thoughts?
No, I think I gave my opinion.
Yeah, okay. Before we end off, I'd like to ask if you have any further comments regarding your work or Nobel Prize that we haven't touched yet. So any comment that you would like to leave us with, please feel free to.
Okay, I am glad that you invited me. I am, as I said, I am also the president of some foundation, and we provide some discussions online as this webinar today. And one of the discussions was also about the Nobel Prizes. And okay, it's in Polish, in fact, but some say detail kitchen of how all this is dealt with by the Swedish Academy is also very interesting. But what I would like to mention again is that despite there are some inaccuracies, I mentioned already this inaccuracy.
I think
the right people, to the right scientists who really contributed the field in various topics of science like physics, chemistry, medicine, etc. So I think that this is the most important message, and this is the message which should go to the society, that scientists, us, are working hard and working for the good. Thank you.
Yeah, thank you very much. Professor Chana and Professor Hagrichar, do you maybe have some additional comments?
Yeah, I maybe I mean I don't want to start again a new question, but certainly as a researcher, I'm always thinking of what is the next breakthrough. Certainly, first thinking about our own field, field of discipline in the condensed matter physics, and this is really quite challenging question because you know, we are relying on many discoveries, but we are talking about decades. I mean, even if something is really worth a Nobel Prize, normally it takes quite a long time to be proven, to have its impact, etc. I mean, I think one of the most fastest one was for graphene, let's say, and it didn't take that long. But I'm always thinking, what's going to be the next discovery in my own field, and of course, and how we can maybe contribute to it. We all contribute in some sense to the science developments of the science, and there is always, as we also discussed, some who get a Nobel Prize, but it's of course a work of the whole community that makes it possible. So that is maybe for me one of the important questions to how we proceed. What is next? What comes next?
Thank you
That
very much.
intrigues me.
Professor Janet, maybe some final comments from you as well.
Yeah, I just would like to mention that indeed Nobel Prize announcements are kind of a celebration of science in general, and I hope our society keeps science among one of its treasures.
Yeah.
Pursue.
Thank you. So I would like to thank everyone that has joined this MDPI webinar. First of foremost, I would like to thank to our three speakers here today. Thank you very much for agreeing to take your time and have this discussion with us. We really enjoyed it. And also, I would like to thank to all of the viewers that are attending this webinar as well. Just a reminder that the recording will be available soon on the webinar website, and then you can access it and go over today's discussions once again. So thank you very much to all of you, and I wish you a nice rest of the day. Thank you.
Thank you very much and goodbye. Bye-bye.
Thank you very
Goodbye.
much, and thank you all of you for organizing this. Have a nice
Thank
day.
you.
Bye-bye.